We're going to talk about the function, um, what it is. We're not going to get too deep into what functions are, but just kind of give you a first off a connection between equations and functions, and then more or less just a little informal definition. But this is going to be part one here. I'm going to break this up into two pieces. So let's talk about the relationship of two variables. Now, in some previous sections, we talked about this equation here. F represents Fahrenheit and C Celsius. We say that the value of F depends on C. The value of F depends on C. Let's look at another one. V in this case represents volume. It's kind of one you need to memorize also. Alright, we say that the volume depends on the radius. The volume depends on the radius. We refer to the volume as the dependent variable, so this is known as the dependent variable. I'm just going to kind of shorten up the word dependent. You'll find me doing a lot of that, just writing it shortly. Alright, and this is R is known as the independent variable. The relationship between the independent variable and the dependent variable goes like this. For every value that corresponds to the independent variable, there's only one and only one value that corresponds to the dependent variable. This relationship is known as a function. Now, the connection, we want to make a connection here. Between an equation and a function, because in the past we've been talking about equations and how to graph them, but let's try to make this connection now. We have x plus y is equal to 3, so this is a real simple equation. Now let's solve for y in this equation, and we're going to keep y over here on the left hand side of the equal sign. So I'm going to subtract x from both sides, or really the way I look at it is I'm just going to move x over here. To the right of the equal sign, this becomes negative x plus 3. So we isolated y and placed it on the left, and of course it doesn't matter which side you place y on. But usually this is the convention that we normally use. So y is the dependent variable and x is the independent variable. Now let's read this. This reads as y is a function of x. Y is a function of x. Now let's say that I'd want to evaluate this function. So we would say we're going to let x equal 0, therefore y is going to equal, so I plug 0 in for x here and y will equal 3. Now if we're talking about this function to a friend, we need to give it a name. Or we're going to end up having to go, hey, remember negative x plus 3? Yeah, that's really kind of inconvenient. But if we're talking about, hey man, remember the function f, then he'll know what you're talking about. So now let's talk about some notation. Let's let f of x equal negative x plus 3. The name of our function is f. F of x is our dependent variable and x is our independent variable. Now this type of notation is extremely useful, especially if we're going to evaluate this function. If I said f of 0, then that means you're going to take 0, which is going to be being plugged into our independent variable here. So we're going to plug 0 in for x. Therefore, f of 0 is equal to 3. Now we can call our function anything you would like. Here's some examples of some functions that you're going to see in the future. C, let's say, in this particular function here, is the cost. So that may represent the cost of an item being made. R, the revenue, and P, the profit. So we can call our function anything we say. But if I'm at the table and we're talking about a business and we're talking about its profit, and I happen to write P of X on the paper, well, it's going to usually be known as P represents the profit. Now, in Cal 1, we mostly work with these single valued functions. However, in Cal 3, we kind of jump out of the plane and go into higher dimensions. And our function notation may be written like this, right, where we have multiple values. And I'm going to just kind of end this on the connection between an equation and a function, and some function notation here. And in part 2, we'll get into more of the definition of what a function is.